students, now today we are going to do the questions number 6 from the exercise 13.8. A hemispherical tank is made up of an iron sheet 1 centimeter thick. If the inner radius is 1 meter, then find the volume of the iron used to make the tank. The tank is hemispherical in nature. You can see this tank, it is hemispherical. It is having the inner radius that is equals to 1 meter. This is a hemispherical tank made up of iron. The inner radius, that is R, that is equals to 1 meter. So inner radius is R is equals to 1 meter, and the thickness of this hemispherical tank is 1 centimeter. This is 1 centimeter thick. 1 centimeter thick. So outer radius will be 1 meter plus 1 centimeter. So we'll convert this centimeter in meter. So it becomes 1 meter plus 0.01 meter. 1 centimeter is 0.01 meter. So if we add this, will become 1.01 meter. So the outer radius denoted by capital R is 1.01 meter, and the small r, that is the inner radius, is 1 meter. Now we have to find how much volume of iron is used to make the tank. Now see, since it is a hemispherical bowl, hemispherical tank, you can say, so this is the volume of material that we have used. So volume of material that we have used is the external volume of a hemispherical tank minus inner volume of the hemispherical tank. So volume of iron used to make it, volume of iron used to make hemispherical tank will be equals to hemispherical tank, that will be equals to 2 upon 3 pi capital R cube, this is the external volume, minus internal volume, that is 2 upon 3 pi small r cube. So we'll take 2 upon 3 and pi common, so we'll get r cube minus small r cube, capital R cube, that outer radius, this is inner radius. So now let us put the value, 2 upon 3, pi is 22 upon 7. Now this is capital R, that is equals to 1.01 meter, so 1.01 cube minus 1 cube. Now let us solve it further. 2 upon 3 into 22 upon 7. Now the value of 1.01 whole cube, that will be equals to 1.030301 minus the cube of 1 is 1. So it is 2 upon 3 into 22 upon 7 into, now 1.030301 minus 1, that will be equals to 0.030301, and when we'll solve it, it will be equals to 0.06348781 meter cube. So the volume of the iron used in making the tank is 0.06348781 meter cube. Let us solve the question number 7. Find the volume of a sphere whose surface area is 154 centimeter square. Now in the question it is given that surface area of sphere is 154 centimeter square. Surface area of sphere is given, and that is 154 centimeter square. We know the formula of surface area of sphere, that is 4 pi r square is equals to 154. By using this, we will be finding the radius of the sphere. 4 into 22 upon 7 into r square is equals to 154. So r square will be equals to 154 into, we will do the cross multiplication, 7, and this is 4 into 22. So 22 ones are 22 and 22 sevens are. So 7 sevens are 49. 49 upon 7 7 is 49 upon 4. Now to find the value of r, we'll find the square root of 49 upon 4, that is equals to 7 upon 2 centimeter. So the radius of the sphere we got is 7 upon 2 centimeter. Now we have to find the volume of sphere. Volume of sphere, the formula is 4 upon 3 into 4 upon 3 pi r cube. So 4 upon 3 into pi 22 upon 7 into r cube. R we have got 7 upon 2. So we'll write 3 times 7 upon 2 into 7 upon 2 into 7 upon 2. This 2 to the will cancel this one, and 2 11s are, this 7 and 7 will cancel. So now what we are having, 11 into 7 into 7, that makes it 539 upon 3. Now when we'll solve it, we'll get 179.666, it is non-terminating, centimeter cube. So when we do the round off, it will become 179.67 centimeter cube. So the volume of sphere is 179.67 centimeter cube. Now let us solve the question number 8. A dome of building is in the form of hemisphere. From inside it is whitewashed at the cost of rupees 498.96. If the cost of whitewashing is rupees 2 per meter square, find the inside surface area of the dome and the volume of air inside the dome. Now you can see this is the shape of a dome. This has to be whitewashed, and the shape of the dome is hemispherical dome. So it has to be whitewashed from inside, from this side. That means we have to find the inner curved surface area, and the cost of whitewashing per meter square is rupees 2, and total cost is 498.96. So we'll write inside surface area of dome multiplied by cost of whitewashing per meter square is equals to total cost. Now inner surface area and of dome, inner surface area of dome is equals into cost of whitewashing per meter square is rupees 2, and total cost is 498.96 rupees. So we have to find we will find inner surface area, that will be equals to 498.96 upon 2. When we solve it, it becomes 249.48 meter square. So the first answer we have received, that is the inside surface area of dome is 249.48 meter square. Now by using this we will find the rate, because we have to find the volume of air inside the dome. So volume of air inside the dome, hemispherical dome, is 2 upon 3 pi r cube. So first we have to find the radius. For that, inner surface area is 2 pi r square, because since it is a hemispherical dome, so it is 2 pi r square, that is equals to 249.48. So 2 into 22 upon 7 into r square is equals to 249.48. So r square will be equals to 249.48. We will cross multiply this 7 up upon 2 into 22. So when we will solve this r square, that will be equals to 39.69. So r will be equals to under root of 39.69 39.69. That we'll find the square root of 39.69. That will be equals to 6.3 meter. So the radius of the hemispherical dome is 6.3 meter. Find the volume of air inside the dome. So volume of air inside hemispherical dome, and we know the formula of volume of hemisphere, that is 2 upon 3 pi r cube. Now we have calculated the radius, that is 6.3 meter, that is 2 upon 3 into 22 upon 7 into 6.3 into 6.3 into 6.3. Now let us solve this. This will cancel here. 3 2 just 6, 2.1. Now again we'll cancel this. It becomes 0.3. So now 2 into 22 into 0.3 into 6.3 into 6.3. When we'll solve, we'll get the answer approximately equals to 523.191 meter cube. So total volume of air inside the hemispherical dome will be 523.91 meter cube. Now let us solve the question number 9. 27 solid iron sphere, each of radius r and surface area s are melted to form a sphere with surface area s dash. Find the radius r dash of the new sphere and the ratio of s and s dash. Now it is given that 27 solid iron sphere are melted to form a single sphere. So when we are melting an object and converting into another object, the volume remains the same. So the volume of new sphere which are made by melting 27 iron solid sphere will be equals to 27 into volume of solid iron sphere. Now because 27 solids are melted, solid iron sphere is melted to make a one single sphere. So here the volume of new sphere will be 4 upon 3 pi r dash cube, because radius is r dash, is equals to 27 into 4 upon 3 pi r cube. So 4 upon 3 will cancel, pi will cancel with this pi. So r dash cube is equals to 27 r cube. So r dash cube will be equals to cube of 3r. So comparing this, r dash will be equals to 3r. So we got the first answer. Radius r dash of the new sphere is 3 times the radius of the iron sphere. Now we have to find the ratio of s and s dash. So we write s upon s dash. This s and s dash is the surface area of the iron sphere, earlier iron sphere, and the surface area of the new iron sphere. So the formula is 4 pi r square upon 4 pi r dash square. This 4 and 4 will cancel, pi will cancel with this pi. So now it is r square divided by r dash square. R dash is how much? 3r. So it will be the square of 3r. So that is equals to r square upon 9 r square. This will cancel, r square and square will cancel, 1 upon 9. So the ratio is 1:9. So the ratio of s and s dash is 1:9. Now let us solve the last question of this exercise. A capsule of medicine is in the shape of a sphere of diameter 3.5 millimeter. How much medicine in millimeter cube is needed to fill this capsule? Capsule is in the shape of a sphere and the radius is given, that is diameter is given 3.5 millimeter. So radius will become 3.5 upon 2 millimeter, that is 1.75 millimeter. Now in this we have to find how much medicine can be filled in this. So volume of medicine will be equals to the volume of spherical capsule, and we know the formula of volume of sphere, that is 4 upon 3 pi r cube, that is 4 upon 3 into 22 upon 7 into r. R is 1.5 millimeter, 1.75 millimeter, 1.75 into 1.75 into 1.75. When we'll solve this, we'll be getting the answer 22.458 millimeter cube, that is approximately equals to 22.46 millimeter cube. So the volume of medicine which can be filled in the capsule is 22.46 millimeter cube.